Here we're going to talk about simplifying complex fractions. So a complex fraction is a rational expression whose numerator, denominator, or both contain one or more rational expressions. So for example, like 2x over 4y all over 3x squared over 5y to the third, something like that. Where you have fraction over a fraction, but we have rational expressions in there also. So simplifying complex fractions, there's a lot of different methods, really two main methods, but there's a lot of different ways that you can think about a complex fraction. So I'm going to show you a couple different ways to approach this. So the first way, for like number 1a, we have 18 over 5x all divided by 9 over 5x. So the first way that you could think about this is if I have a fraction, like if I had the fraction 2/3 divided by 1 over 3, whatever. I can think about this as 2/3 being divided by 1/3, so that means I'm multiplying by 3 over 1. If I'm dividing by a fraction, I multiply by the reciprocal. I could do the same thing here, 18 over 5x times 5x over 9. I can take this division of that fraction and turn it to multiplication and take the reciprocal. So what ends up happening is the 5x's cancel, 9 and 18, 9 goes into 9 once, 9 goes into 18 twice. So all we're left with is just 2, I think, right? Yeah, because 5x is canceled, 2 times 1 is 1, and then we just have 1 on the bottom. So we would just get the answer of 2 there. Cool. That's pretty interesting. Now, another way to do it, which I'll talk about on letter B, is rather than taking it as like division of a fraction, you can multiply by the LCD both top and bottom, but you have to look at the whole problem as a whole, like look at all the denominators, both denominators, and find that LCD, or in this case, in this one, and I'll show you this a couple times, but in this one, the LCD is just going to be x minus 4, so I'd multiply the top by x minus 4, I'd multiply the bottom by x minus 4. So on the top, x minus 4 times 5 over x minus 4 is cancel, leaves me with 5. And on the bottom, x minus 4 times x over x minus 4 is cancel, leaves me with x. So I would just have 5 over x. And that's it. 5 over x. All right, let's keep going. So on this one, like I was saying, you can just, like, the problem I have with like this method of like just taking it as division of multiplication is because when you get to this scenario, like number 2, like that gets a little bit difficult because what you'd have to do is you'd have to deal with like each fraction. So you'd have to take 5 over x plus 2 over x squared, and you'd have to like add those fractions together. So you'd have to make the denominator here x squared times x, 5x plus 2 all over x squared. I'm not going to do this fully, but you'd have to do that, and then you have to do that to the bottom also. And it creates a lot of legwork and a lot of areas where you can make potential mistakes. So that's why I like to try, if I can, I like to try to work with the LCD method, because that way you can wipe out really complicated looking fractions. So the LCD here, the problem though is when, you know, the LCD is a little bit more complicated than just like an x or an x squared or just a single like x minus 4. So the LCD here, I have x to the first, x to the second, x to the second, x to the first. So the LCD is just going to be x to the second. So that means I'm going to multiply the top by x to the second, multiply the bottom by x to the second. And when I do that, x to the second times 5 over x to the second times 2 over x squared, x to the second times 5 over x is 5x, plus x to the second times 2 over x squared is the x squareds cancel out, so I'm left with 2. And then on the bottom, we are going to do x squared times 25 over x squared, which is just going to be 25, minus x squared times 4 over x is going to be 4x. So then there, we can't really do anything else. There's nothing that could factor out. There's nothing that could simplify. So then that would be our answer for number 2. And like I was saying before, when you do like this concept of just division of a fraction, like you have to deal with this first, deal with this by adding them together, and then you'll just get like a fraction over a fraction, and then you could do the multiplication, which is fine. Nothing wrong with that method. Just, I don't know, it just gets a little messy at times, for me at least. So let's take a look at number 3. I'm gonna just stick with the LCD method. So the LCD here is going to be, I have a couple of factors of x. So I'm gonna have an LCD of x times, and then I have a couple factors of x minus 1. So I need to multiply the top and bottom by x times x minus 1. So on the top, when I multiply that out, see what happens. X times x minus 1 times x plus 4 over x, the x's cancel, so that leaves me with x minus 1 times x plus 4, and then x times x minus 1 times 6 over x minus 1, the x minus 1's cancel, so that's going to leave me with minus 6x, so x times 6, x minus 1's cancel. And if you're thinking about multiplying those binomials together, you are going to have to do that. So let's keep going. So x times x minus 1 times x plus 1 over x, and then x times x minus 1 times x plus 1 over x minus 1. So the first one, the x's are going to cancel out, leaving me with x minus 1 times x plus 1 plus the x minus 1's then cancel on the second multiplication, x times x minus 1 over here. X minus 1's are going to cancel. That leaves me with x times x plus 1. Really hoping for some nice simplification here. Let's see, we're going to multiply these binomials together. So x times 4, negative 1 times x, negative 1 times 4. So x times x is x squared. X times 4 is 4x. Negative 1 times x is negative x. Negative 1 times 4 is negative 4. Minus 6x all over. And then on bottom, x times 1, negative 1 times x, negative 1 times 1. So x squared plus x minus 1 plus x times x is x squared plus x. So x times x and x times 1. Let's keep simplifying. Do have some like terms here and here and here. Here, 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 and here and here. So I have quite a bit of like terms. These are like terms, these are like terms. Okay, so on top I get x squared, 4x minus 1x is 3x. 3 minus 6 is negative 3x minus 4. On the bottom, x squared. So first of all, let's do the x's right here, cancel out. X minus x is 0. And then I have that x. That's still going to be there. But then I have this x squared plus x squared. Let me make sure that something didn't drop out that should drop out. Okay, I think we're good. So that's going to be 2x squared. X squared plus x squared is 2x squared. Then I have that plus x, and then we have that minus 1. On the top, I could factor that. That's two numbers that multiply to negative 4, add up to negative 3. That's going to be x minus 4 times x plus 1. So that factors. What about the bottom? So let's see, two numbers that multiply to negative 2 add up to 1 is going to be 2 times negative 1. Okay, so 2x squared, so let's factor this out. So 2x plus negative 1x, so minus 1x minus 1. So replacing the middle term, those two terms that work, 2x and negative 1x. Factor by grouping. Factor out of 2x. Left with x plus 1. The second set of parentheses, negative 1x minus 1, I could only factor out a negative 1 there. So that's going to be x plus 1. Same thing, x plus 1, 2x minus 1. So I get x plus 1 times 2x minus 1, and look at that. After all of that, look what happens. X plus 1s cancel out. So that is going to leave me with x minus 4 over 2x minus 1 for all that work. And yeah, if you went the other way with this one, so if you try to make the denominators the same and like dealt with the top here, you'd have to multiply this by x minus 1, multiply this by x, and then you'd have to do all that legwork, and then you'd have another fraction on the bottom, do all that legwork, and then you'd have to simplify it. Like it gets really, really messy, where I don't think this method here, multiplying by the LCD, is extremely straightforward or anything like that. I'm not saying this is like easy by any means, but it's just a cleaner, nice approach to solving this. So there it is. Got to multiply by the LCD, a lot of multiplication, factoring, and then simplifying from there. Now, number 4 and number 5, the last two questions of this, we have negative exponents. So let's first rewrite it with positive exponents, and then we will see what happens. So x to the negative 1 is 1 over x. I'll write it right here. 1 over x. Over x to the negative 2 is 1 over x squared. So remember, negative exponents that bring this down, bring this down. And the reason that I'm not, like, you might be thinking, like, well, x to the negative 1, why aren't you going down to the denominator? Why aren't you writing it like that? The problem with that is what you would be doing is you'd have this, like, x times 1 over x squared. Like, I don't know, it just gets a little bit messy. But the intention here is that you're supposed to just be creating this complex fraction where it's just 1 over x, and then this is 1 over x squared plus 1 over y to the 8th, like that. And then you just have a complex fraction, so you just manage it by multiplying by the LCD. Now you could do the method I was just talking about where you bring this all the way down, it becomes x times 1 over x squared plus, it's fine, but then you have to simplify it back, like rewrite it, like, and it just gets, there's a lot of different messy ways. Complex fractions are never clean. So you really just want to take a streamlined, cleanest approach as you possibly can. So the LCD here is going to be y to the 8th, whoops, y to the 8th, x to the 2nd. So I'm going to multiply the top by y to the 8th, x to the 2nd. Multiply the bottom by y to the 8th, x to the 2nd. So on top, y to the 8th, x to the 2nd is going to be y to the 8th x, because x to the 2nd over x is x, over, and then y to the 8th times x to the 2nd over 1, or times 1 over x to the 2nd. That's going to be x to the 2nds cancel out, leaving us with just y to the 8th there. Y to the 8th x to the 2nd times 1 over y to the 8th. Y to the 8ths are going to cancel, leaving us with just x to the 2nd. So plus x to the 2nd. And that's all I could do. There's nothing else I could do. There's no simplifying that could be made there. There's nothing. That's it. And last one, number 5. Looking a little complicated, so let's be careful how we navigate this one. So this is 4 over x, because this is just x to the negative 1, so the x just has to go down. Plus, this is 4x to the negative 1 in parentheses, so that whole entire statement needs to go down, so 1 over 4x. All over x to the negative 1 is 1 over x, plus 4x to the negative 2, only the x has the negative exponent, so 4 over x squared. What's our LCD? Looks like the LCD is going to be 4x squared, because this one has a 4, this denominator has a 4, and this denominator is an x squared, so the LCD has to be 4x squared. So I'm going to multiply everything by 4x to the 2nd. So on the top, 4x to the 2nd times 4 over x is going to be 16x. X to the 2nd over x is x. 4 times 4 is 16. Plus 4x squared times 1 over 4x. 4's cancel out. X to the 2nd over x is just x. So let me show you that one. 4x squared times 1 over 4x when I multiply over here. 4's cancel. So then you'd have x squared over x. That's just x. So that's why I just get plus x there. On the bottom, 4x squared times 1 over x. That's going to be 4x. Because x squared over x is x. 4 times 1 is 4. Plus 4x squared times 4 over x squared. X squareds cancel out. 4 times 4 is 16. And the only thing we could do is 16x plus 1x is 17x over 4x plus 16. And I don't have any other simplifications that can be made. So there would be our answer on that one. Yeah, so a little bit messy. It's got to be careful with negative exponents. Notice that only this x has a negative. So only that one was rewritten on the bottom. And then this whole entire 4x is being raised to the negative 1. So that whole entire 4x needs to be move down to the bottom there. So lots to pay attention to here.